Have you ever wondered what lies at the bottom of the world's deepest lakes? We're diving into an unexplored frontier, where immense pressures have carved out unique underwater worlds. Discover the geological forces that shape these colossal basins and the bizarre ecosystems that have adapted to life in the extreme depths, revealing a hidden side of our planet. What hidden forces carved these impossible depths? Today, we re-peeling back the layers of water and time to reveal ancient geological secrets and ecosystems that seem almost alien. The story of our planet's deepest lakes often begins with a force powerful enough to tear continents apart. Tectonic plates, imagined two massive sections of the Earth's crust slowly pulling away from each other. Over millions of years, this divergence creates immense cracks in the surface, known as rift valleys. These aren't just simple trenches. They are colossal scars that deepen and widen with every tremor and shift in the Earth's mantle. As the land sinks between these diverging plates, it forms a basin so vast that it begins to collect water from rivers and rainfall, eventually giving birth to a lake of staggering proportions. The most spectacular example of this process is Lake Baikal in Siberia. It's not just the world's deepest lake, it's also the oldest, at around 25 to 30 million years. The rift valley it occupies is still active, meaning the lake is constantly, albeit slowly, getting deeper and wider. This ongoing geological activity, a slow-motion dance of continental plates, is the architect behind Baikal's mind-boggling depth of over 1,600 meters. Animations can help us visualize this incredible process, to landmasses pulling apart, the ground between them collapsing, and water rushing in to fill a chasm that will continue to grow for millennia. It's a reminder that our planet is a living, breathing entity, constantly reshaping itself. But not all deep lakes are born from the fiery heart of the Earth's tectonic activity. Some owe their existence to an entirely different and much colder force. During the ice ages, massive glaciers, some several kilometers thick, crept across the continents. These weren't just static sheets of ice. They were colossal rivers of ice, grinding and scouring the landscape beneath them with unimaginable force, armed with rocks and debris frozen into their bases. These glaciers acted like giant bulldozers, carving out massive troughs and valleys in the bedrock. When the climate warmed and these immense ice sheets began to melt, they released phenomenal amounts of water. This meltwater filled the deep basins the glaciers had just carved, creating some of the most famous lake systems on Earth. The Great Lakes of North America are a prime example. Their incredible depths and vast surfaces are a direct legacy of the Laurentide ice sheet, which once covered most of Canada and the northern United States. Visualizing the scale of these ancient glaciers is awe-inspiring. They were so heavy, they literally depressed the Earth's crust, and their slow, grinding movement was a relentless force of erosion that sculpted the land on a continental scale, leaving behind the deep, cold water lakes we see today. From the slow tearing of continents and the grinding power of ice, we turn to a much more explosive origin: volcanoes. Some of the world's most stunningly beautiful and deeply mysterious lakes are found nestled within the craters of ancient, dormant, or extinct volcanoes. When a massive volcano erupts, it can empty its magma chamber so completely that the entire structure collapses in on itself, forming a huge basin called a caldera. Over time, these calderas fill with rainwater and snowmelt, creating what are known as crater lakes. These lakes are often exceptionally deep and circular, with incredibly steep sides that plunge directly into the abyss. What makes them truly unique are the conditions within. Because of their volcanic origins, the water can be rich in minerals and gases seeping up from the Earth's crust. Geothermal vents on the lake bed can create pockets of warmth, leading to unusual chemical compositions, and often giving the water a brilliant, surreal color. Ortega's Crater Lake is a perfect example, formed in the collapsed caldera of Mount Mazan. Its pristine, intensely blue water is a testament to its isolation and volcanic birth. These lakes are like geological jewels, born from fiery destruction and now holding serene, deep waters that hide the secrets of their violent past. So, we have these incredible depths, carved by tectonics, glaciers, and volcanoes. But what about life? You might think these dark, high-pressure environments would be barren, but you'd be wrong. The deep waters of these lakes are home to some of the most fascinating and bizarre ecosystems on the planet. Here, life has adapted to conditions that would be instantly lethal to most surface-dwelling species. We find creatures known as extremophiles, organisms that thrive in extreme environments. In the crushing pressure and perpetual darkness of Lake Baikal's depths, unique species have evolved in complete isolation over millions of years. One of the most famous is the Baikal seal, or Nerpa, the world's only exclusively freshwater seal. How did it get there? Thousands of kilometers from the nearest ocean. It's a biological mystery. Deepest still, we find strange, translucent fish and countless species of invertebrates that have adapted to live without light, feeding on organic matter that drifts down from the sunlit waters above. This is a world driven not by sunlight, but by chemical energy and the slow rain of nutrients from above. The scientific exploration of these deep lakes is truly a journey into the unknown, using remotely operated vehicles, or ROVs. Scientists are just beginning to scratch the surface of what lies beneath. Each expedition brings the potential for new discoveries, new species, new insights into how life can exist in extreme conditions, and new clues about the geological history of our planet. These deep lakes are natural laboratories, holding answers to questions about the origins of life, not just on Earth, but potentially on other worlds in our solar system that might harbor liquid water beneath icy shells. These deep lakes are more than just bodies of water. They are living chronicles of our planet's tumultuous history. From this low, inexorable pool of tectonic plates, to the monumental sculpting power of ancient glaciers, and the violent explosions of volcanoes, they are monuments to the geological forces that have shaped our world. And as we continue to explore their dark, pressurized depths, we are reminded that our planet still holds profound mysteries. The story of Earth is one of constant change, and beneath the calm surfaces of these lakes, the next chapter is always being written. What other secrets are waiting to be discovered in the abyss? The adventure is far from over. Thank you so much for joining us on this journey into the Earth's deepest mysteries. If you found this as fascinating as we did, don't forget to like this video and subscribe to our channel for more deep dives into the wonders of our world. We'll see you in the next one.